Hello, good morning to everyone. In the previous talk, we have heard a lot about the technology. So in this talk, I will try to combine some philosophical things and the technology and its applications, which can be turned into new types of innovations. This master's program is all about the pervasive computing and mobile communication for sustainable computing. In this talk, I will try to develop a model which I would like to tell consilience model of sustainable computing. So first of all, I would like to introduce the lecture outline of my talk. First of all, I would explain the methodology of consilience, and then I will try to formulate the framework of sustainable computing and the tools that can be used to implement that framework will be presented. Then I will show you some applications of this model, like in the area of irrigations, flood predictions. Flood, I think, is a problem for France and Germany and all over the world. And then on the meditation side, and I will introduce some of the activities that going on in Bangladesh in terms of sustainable computing that will be introduced. So first, take a very simple definition of sustainability. You know about the father of fuzzy logic, Lutfi Jada. So according to him, sustainability implies that you are happy with the situations and you would like to continue. So here, the most important things that we need to build a situation that with which we are happy and we would like to continue. This is the challenge, building the situation that you are happy and we would like to continue it. So this can be achieved by developing a new computing paradigm. So if we consider the intelligent system, which I will talk very soon, that is the sensing and acting in the environment should need to be done in an intelligent way. However, there are other definitions of sustainability, that is somebody considered is as the continuous learning over knowledge and time space, or the regeneration of the knowledge. This can also be considered as sustainable. So let's have a look on my model, that is the consilience. So basically this is premised in some belief space. So the main idea is that unity of the knowledge, that is we need to combine, integrate the methods, that is the converging philosophy. So how can we achieve that? We need to consider three elements, that is the interactions, integration and evaluation. If you can do that, then there could be a continuous flow of knowledge and the generation from the consilience. And this knowledge flows could determine the policy variable technology that will bring well-being or the sustainability to the society. So here is the model. As you can see here, consilience knowledge flow. So we are considering the epistemology, that is the theory of knowledge, that is we are considering some belief space. And then through the discourse, the discussion, we are formulating the knowledge for certain problem, for example, under study or the domain. And then this knowledge can be induced in some policy, or the organization X can be the experience, organization policy. And when we can apply this knowledge to solve the real world problem, then we can evaluate, then it will ensure the sustainability, or we can say social well-being. So you can consider this as the sustainability functions. However, this is not one process. This is a multiple process, and it's recursion over multiple processes. So the beauty of this model is that, so when we are deriving the knowledge from the epistemology, then there is a reasoning process that carries on, is a deductive reasoning. And when we are inducing the knowledge in the policy of the organizations, so it's an inductive reasoning. So one of the important aspect of this model is that we are introducing the concept of circular causations. That is it's not about the David Hume's causality, but the causation should be in the two ways. For example, P to Q and Q to P. So one thing, that is the interaction we are talking about, that is if the relationship between P to Q, this is interaction, but if it is P to Q and Q to P, then it is producing the circular causation, that is it is establishing the integration between the pairs, two variables, that is it is ensuring the friendship. So this integration is very important. This integration because takes you to the next level of the system, which is called the evaluations. So details of this model we have elaborated in our book known as Computing Reality, published in 2008. You will find details of this model in this book. And you can see the model of systems of circular causation. So if you analyze the previous model, then we can identify the three things. One is the epistemology, and then the ontology, then the ontic. So through the epistemology, through some knowledge formation procedures, we can generate new knowledge. We can tell this new universe of knowledge, theta, x, theta. Then if we can apply this formalism to solve some real world problem, then we can evaluate. So this is the sustainability functions. So you can see there is a continuous integration between the components. So in this way, they are connected, they are forming a space of cybernetics. So in our paper, Neurocybernetics of Socio-Scientific Systems, published in Mind and Society, you will find the details of this model in this paper. Sorry. And now what is the problem with the present computational model? So if you'd like to develop a software, that is, you need to go through some process, system analysis, conceptual model, logical model, then the physical model. So the problem is that sometimes we are not able to establish the interlinkages of the integrity or interrelationship between the stages. So consequently, it is difficult to obtain the sustainable software, or what we are talking about, the eco software, for example, because there is absence of circular causations. So, and the philosophy behind these machines, basically based on the, about the 16th century's philosophy. If we consider the Europe, we got the philosopher like the Descartes or the Leibniz. So since the philosophy of this machine is based on this philosophy. That's why these machines is something like the mechanistic machines. But in order to have a sustainable computing, we need some sorts of not mechanistic but romantic machines, so which can be achieved through this framework. So here is a very fundamental components of intelligence system. As you can see, intelligent machines sense the environment, is act environment. So only the sensing the environment or acting in the environment will not make the system intelligent. That is, it will not demonstrate the intelligent behavior, but we need some sorts of knowledge or the consciousness or the cognitions of the machines that will make. So only the rationalistic way of looking at the system is not enough, but we need something else. So here I would like to have another model, consilience models of computing of sustainability. As you can see, there is a knowledge. However, knowledge consists of facts and rules. So when we are sensing the environment, we are perceiving the environment. This has also rules to form the knowledge. Then consciousness depends upon the knowledge. There are three types of consciousness. One could be the self-consciousness. Another one is the empirical consciousness. Another one is the holistic consciousness. So in the self-consciousness, the reasoning process is the deductive reasoning, while in the empirical consciousness, the deductive process is the inductive reasoning. And in the holistic consciousness, we are combining both self-consciousness and the empirical consciousness, as you can see from these equations here. So we can mathematically we can define the consciousness in this way. However, what about the sustainability? We can have this equation, that is we can say degree of change of consciousness over knowledge. So if we would like to make a machine which only sense and acting, this is not enough, but the machine needs to have a knowledge and also have a consciousness, and there should be a continuous integration among the knowledge and the consciousness. So in this way, the intelligence system could become sustainable. So I have elaborated the conscious models of sustainable computing. Now I would like to how we can implement this sustainable model of computing. So there could be a way, that is, if we can integrate the pervasive computing or the Internet of Things with the belief rule-based expert system that we have talked about for last couple of years. So why we need the belief rule-based expert system? Because the problem of the world is very complex, like for example frauding problems. So the problem is almost unstructured, so it consists of lots of uncertainty. So that's why we need a new paradigm of computing or developing the expert system. So if you combine the IoT with the belief rule-based expert system, then the computing will become sustainable. That is, the situation will continue. So here you can see the model of the at the implementation level. That is the heart of the conscious model, as I told you, that is the interaction of the integration and then the evaluation. If you can integrate IoT with the belief rule-based expert system through a circular causation, then we will able to obtain the sustainable computing. So IoT can play a role in the sensor aspect of the intelligence system as well as at the actuator, and we can develop the algorithmic things using the belief rule-based expert system, and also it has a very important role to play in the action, because the action, if we can follow the instruction from the belief rule-based expert system, then the action could be sustainable. Now I will show some of the applications of this model. So you see, irrigations of the agriculture is very important things, especially in the country like Bangladesh, and water resource is very important. That is, we need to make sure the optimum use of the water resources. So that's why we have developed smart irrigation systems. I am now elaborating the architecture of this smart irrigation of the wireless sensor networks. Then we are using the server, and then we are using a pump machine, and we are supplying the power to that pump machine from the solar energy, renewable energy. So sensor is basically collecting the moisture data, and through gateway it is sending the moisture level data to the server. This server could be implemented in the cloud as well, and farmers can get the moisture level data of its crops field through the mobile, through SMS, for example. And then by developing some sorts of intelligence system using the belief rule-based expert systems, some decision parameters can be sent to the control panel of the pump machine. Then the when it get the data from the on the moisture content, then it will run the pump machine. Then when the field will become saturated, again it will collect the data, then it will be a stop. And the energy supplied to this that is machine's pump machine through the solar energy. And here is the implementation of our system. This is the prototype systems. Here is the wireless sensor network things, and the solar power panel. There is the crops field. So we have demonstrated this very prototype in one of the innovation fair held in our country, and it attract lots of attraction from the audience. So let's explain our sustainable model of computing in these smart irrigation systems, how it works, how it ensures the sustainability to the farmers. Say, for example, this is a crops field, and we are deploying sensors at R1, R2 different regions. So we are collecting the moisture level data from the crops field, and so it's ensuring some sorts of level of interdependency that I would like to define at the cognition. Then it is also creating the complementarity or intercausal relationship between the regions. What is the degree, what is the consciousness of this crops field? It depends on the knowledge over a space and time, and sustainability, the degree of change of that's the moisture content over a space or time of the knowledge. So what you can see here, when we are collecting the moisture level data from the sensor, then it go through belief rule-based expert system, then it send the decision parameters to the pump machines, then pump machine irrigate the field. When the field becomes saturated, there is no point to run the pump machine, then it will send the signal or the decisions to the pump machine to stop. So in this way, we can make use of the optimal uses of the water resources. So, and also it will increase the productivity of the crops. So in this way, farmers will become happy, situation will become continue. So this is also an example of sustainability that can be ensured through combining the IoT and belief rule-based expert systems. I would like to show another applications, that is the flood. You see, flooding is a very important problem, not only for Bangladesh, right now for France as well. So this is a Swedish Research Council awarded project. In this project, Professor Karl, we are working, we awarded in 2014. So here we will also show you how the concept of sustainable computing working. So basically you can see we are combining the wellness sensor network with the belief rule-based expert systems. So here is the main three components of our systems. That is the wellness sensor network components things, and this is the expert systems here. So this components is working to sense the environment, that is to collect the some parameters related to the say, rainfall or water level, moisture level, this type of data to the by using these components. And when we are doing our research, we are facing some problem, that is the sometimes you can't rely on the sensor data. So we have found some anomalies in the sensor data. So that's why we need to develop some sorts of filtering algorithm to fit the belief rule-based expert system with accurate data. So I will now try to give some idea on the various components of this framework, how the works is going on. So in the wellness sensor network search, that is we are developing different types of scenarios. Our master student Sumit is working here. We have tried with different types of protocols, IP version 6, you can see a 02.15.46 loop and Arduino Mega, and we are employing different types of sensors there. And also the you can see we are implementing the gateway in the Arduino Mega. Then using Wi-Fi or other technology, we are sending our data to the central server where our belief rule-based expert system working. So the idea is that we would like to fit the belief rule-based expert system continuously by getting sensor data. So so we would like to generate the scenarios, we would like to predict the scenarios. So you can see in our next slide, that is when we are facing some problem with the anomalous data, that we have developed some algorithms. You know about there are some association rules based data mining techniques like the binary association rule, fuzzy association rules. But we have developed a belief rule based association rules. So our result, we have tested using the reliability of the result, receiver operating characteristics curves, that you can see that our belief rule based anomaly detection algorithm performing better than the fuzzy association rule or the binary association rule. The reason for this is that this framework is able to address the various types of uncertainty, not only the uncertainty due to the linguistic terms like the vagueness, ambiguity, or imprecision, but in addition to that, it can address the uncertainty due to the ignorance, incompleteness, or other also, but in a very integrated framework. So here is the inference procedures of belief rule-based expert system. Basically, it consists of 4 steps. First of all, when we are getting the input data, for example, from the sensors, then we need to transform it. Then we have a rule base, and then we need to activate the rule. Then we need to do some aggregation of the rule to generate some output result. We use the evidential reasoning based approach, which is a multi-criteria decision based approach. But the beauty of this model is that we can process both qualitative and quantitative data in an integrated framework. So here we have developed a web-based applications which is available online. So here you can see the interface of the systems. This is the belief rule base. So say for example here X8 or X9, these are the factors that are responsible for causing the flooding. So say for example X8 is the meteorological factor, but X12 is the factor related to the human activities. Human activities is also responsible for increasing the flood water level, but some of the factors related to the human activities is not quantitative but qualitative. Say for example human behavior, public behavior. So how can you incorporate this into one framework? So the beauty of elegance of this framework is that you can process both rainfall, say quantitative data, as well as the qualitative data into an integrated framework. So you can, in the next interface, 2 minutes. So in the next interface, you can see the output of the system. That is, we are using the sensor data. You can see the output. So for each mid level of the systems, we can generate this type of scenario. That is, we can show that the jumping of the different variables in the nature which are affecting the flood water level to increase, for example. This type of scenarios can be developed using this type of models. And you can see we are not talking, but we are working close to the field. We have considered 2 case study area. One is Bakkali River in Cox's Bazar, Bangladesh. Another one is Sheleptiu River. Hopefully, Sains River may be included one day. So you can see how the scientists are working here. We have gone to the field. We have tested our system. Professor Carl, IoT is in the hand of Professor Carl, I think, and we are testing our system whether they are working or not. And you can see that is we are trying to use the innovation for the well-being of the people. This is called the sustainability, as far as I am concerned. And we are also using this system because I have time constraint for meditations also due to the self-consciousness, for example. And we have also formed a group in Bangladesh. It is Sustainable Computing Lab. So many people are working here. They are well trained in the BRB and IoT. And there are some systems we are developing in Bangladesh using some indigenous technology, sensors for car parking systems, and also for target detection using some ultrasonic sensors. And we are displaying our innovation, different innovation fair held in Bangladesh. And here I would like to conclude, that is I have demonstrated the consilience model of sustainable computing and the tools to implement this model and application of this model in various domains presented. So thank you very much.